I know this looks like a mess, but it's not. It's a simple circuit. It is a series RLC circuit. I'll explain all the elements in the circuit. This will be our input power. We're going to plug this into the wall. So if we follow a wire, our input power comes to this red lead. Our red lead leads into the light bulb. We're going to go through the light bulb, out the light bulb, and into this coil. Here's our inductor. We're going to go through the coil, out the coil, into the capacitor, and out the capacitor, back to our power supply. So what are all these other wires? Well, I've connected voltmeters across each element so that we can measure the voltage across each element. So let's examine those wires. Here's our voltmeter connected across the light bulb. Here's another voltmeter connected across our inductor, and another voltmeter connected across our capacitor. Let's plug it in and see what happens. Well, gee, not very much of anything is happening, except, wow, we get an RMS wall voltage of 120 volts, but I'm reading almost 200 volts across the inductor, barely anything across the light bulb, and 71 volts across the capacitor. How can that happen when our voltage can only add up to 120 volts? Well, one thing we can do is vary the inductance, and I can vary the inductance by moving this bar. And what happens to the current in the circuit, i.e. the voltage across the light bulb, as I change the inductance? And I don't know if you can tell, but there is a very narrow region where the force on this bar is very strong, and it wants to pull the bar back in. I'll unplug the circuit. Let's compare that. Plug it back in. Thank you very much.